are things going to pick up? Of course, you as a student, you know it's going to pick up. The pace is going to pick up. I have handouts here that I think if I get through everything I want to do today, chapter 3 for the most part will be done. And you check the syllabus, we're supposed to be in chapter 4 at this point, which means I will probably move into chapter 4 tomorrow. So we're going to make up some time here. But I got to make sure we follow these handouts to get through chapter 3. Guys, I'll get the exams back to you. I saw some mistakes that were being made that should not have been made. I'm trying to think how many students actually got a 75 out of 75 and did not have to use their extra credits. I should remember that. I know I had 7 scores, I think 7 scores of 75 out of 75. Some students had a perfect score without using the extra credit. Guys, we'll jump into it. I'll get your exams back to you shortly here. Any concerns? Any questions? Anything at all? We're doing pre-calc in 6 weeks. And here it is, our 3rd week already. Starting the 3rd week. So basically the course is almost about the end of this week, half over. Okay? So chapter 3, like I said, for the most part will be done today. I got to pick a few things on tomorrow to finish it up. And I'll probably start chapter 4 tomorrow and get a big chunk of chapter 4 done. And then that will take me into chapter 5 where I really, really, really want to be. And that's the tree. Okay, so we'll start chapter 5 right at the end of the week. Quiz tomorrow. I think on the syllabus it's going to say there's a quiz tomorrow. Okay, so I'll let you know what type of a quiz it's going to be. It's going to be short. It'll be very short, but 10 points. And then, of course, your exam number 2, I think, is planned for Friday. Is that true? Okay, and I'll let you know more about that exam coming up. No questions? See, I have a few empty seats. Here's that exam. Let's see if those students show up. I know one's running late today. Oh, was it?
Yeah, they go down to 1 lane over at Lincoln.
Oh, maybe that's it, yeah. Okay, they'll come in a little bit later. Okay, guys? Nothing at all to ask about, and we'll jump right into it. Now, we'll try to remember where we were before the exam. Were we doing absolute value? The V-shaped graph, and then we turned that into doing some inequality. Did we? I think we did. Let's do a little quick recap here. I brought this in just for the sake of it. Yeah, here we go. Part 1, a little recap before I jump into chapter 3. And that would be, do this. Let me first label this as quadratics. And underneath here, I better do this first. F of x is equal to this, which we've seen so many times. And of course, that leading coefficient cannot be 0. We've seen that. We've worked with it before. Part B. If you're asked, like tomorrow, to sketch the graph of a quadratic, what should the sketch be when I finish it up? All quadratics graph into it unless something strange happens. What? A parabola. I'm looking for a parabola. Now, if I have the function in this form, I think we looked at this last week, it's easily graphed. It may take a little time, but much easier to graph it looking like this than this. So guys, this part down here is called the vertex form of the quadratic. Now, can anyone quickly tell me why would it be much easier on the quiz tomorrow for you to sketch a given quadratic and you prefer it to be in this form? Why prefer this form than this one? for you?
It's easier to see the transformations.
That's a transformation. In fact, the way it's written right now, I see right now this x subtract h, I didn't give you a number there. What would that x subtract h indicate? What type of a transformation?
Horizontal shift to right.
Thank you. A horizontal shift to the right. It all depends on what that h is. And then, of course, the k on the end is a vertical shift, up or down, depends on the value of the k. And this a out front, something out front, might have what effect on the graph, if any? There you go, I see a student telling me. She said, Professor, you either want to stretch it or shrink it. Is that true? And that's the effect on that. Now, if I have it in this form, which we need, we can quickly name something called vertex, the turning point. And also, a reminder, if A out front is positive, I know the parabola opens up. You know the parabola opens up. If A is negative, the parabola opens down. And I think we sort of went through that last week. Then I'll tell you more about what that one problem on that little short 10-point quiz will be tomorrow. We'll probably have an example before the class is over. This could be something like this. I'll give it to you in this form, and you've got to place it in this form. And then sketch it. Now, can anyone recall the process that you must use when it's given in this form to get to the vertex form? What has to be used?
The vertex formula.
No. What process must I apply to take a form like this? Let's call it standard. Standard form for a quadratic and turn it into the vertex form. We'll go from here to here. What must I do to do it? Oh, we have forgotten. I gotta use completion of the square. That's where you might make a mistake. Now, if you make a mistake on the completion of the square on this quiz tomorrow, in the process, then you're gonna throw the whole graph off. You have to be really careful. Guys, since this is a recap, let's go to this. F of x, and we'll make a problem real quickly here. Just standing here. Just to point out something. Let's say it looks like that. That's a quadratic. Now, just based on what we know, just looking at it, it's going to open what? It's going to open down. Now, where's the vertex right now? I may not know until I put it in this form. So now the process is completion of the square. So guys, I need to be very careful. Take this quadratic. Let me put a y here. I think y is much easier to work with. Just well get this out of the way right now. I got to complete the square. I want this form. Vertex form. Anyone tell me if I intend to complete the square? You guys have done a lot of completion of the square in this class. What's the first thing I should do? Divide everything by? Minus 2, negative 2. That leading coefficient must be a 1. Guys, if I do that, and here's where you've got to be very careful tomorrow, I'll end up with positive x squared minus 5 halves x minus 3 halves. I'm a little scared of this quiz tomorrow. If I have a student who messes up right in here, then it's going to throw the whole thing off. So there's 10 points. At this point, guys, let's move that 3 halves over, and do not let me make a mistake up here. And show I intend now to get ready for this completion. Now, we've done so much. Can anyone see what's required on that blank to finally make a square to complete it? To make this work out for me. Right here. I'll put it here. Of course, if I put it here, I'll put it here. Does anyone see what that number would be right there to complete the square? Yes?
Number 4.
Be careful.
2516.
Well, first you're going to take 1/2 of this, I guess. I think we've had a little routine here. So 1/2 of that coefficient there is stuck in the middle on the x. And that much is what? Negative 5 over 4? That true, guys? And then do what with it? square it. That's why they call it completion squared. Now, it's 25 over 16 here and here. Do we agree? Now, I'm going to quickly put it in the form I have here. I'm scared. If you put the wrong number on this blank, you're going to get your quiz returned back to you on Thursday with a low score. And I can't do anything about it. This is one quiz I can't do anything about it. If you put the wrong number on that blank, then it's going to throw everything off. It's going to throw your graph off, it's going to throw the vertex off, it's going to throw everything off. At this point, there might be some check points here we can go through shortly to see if that is correct. Guys, at this point, I'm going to go ahead and jump on this side and put these two together with a common denominator of 16. Looks like I see 32 plus 25. Am I looking at it correctly? Is that 30? Oh, no, it's not 32, is it? 24. 24 plus 25, what? 49 over 16? So I got this plus this. And of course, on the other side, I hope this is a nice perfect square. That's the whole purpose. And all this together factored would be, if we're correct, looks like it's x subtract 5 over 4, see if you guys agree, squared. So far so good? Now what's my next step? What am I supposed to do next? To finally get the y by itself. Solve for y. And to solve for y, you move this over. Lots of ways to do it. If I do that, you end up with this. Just trying to bring you back to what we were doing last week. And then multiply both sides by what? Negative 2. And you end up, of course, these are cancel, that's what you want. The other side, you got a negative 2 placed on that first term. And I'll throw in negative 2 on the end here, just to show you. These two on the end will give you a positive. Looks like there's a little canceling there. I think it's 49 over 8. Do we agree? Let's hope we don't have a mistake. Now, if we are correct, who on earth, I said this last week, who on earth would think that this, where is it? This function here, which looks pretty good. The original function looks pretty good. This and this crazy thing are the same. Now, why should I want to change that nice, pleasant quadratic here into this vertex form? Because I'm quickly now naming where the vertex is and so forth and so on and graph it. Is that true, guys? My vertex will be located where, just by mere observation? Where are my coordinates of my vertex? There's a horizontal shift to the right, what? 5 over 4? And there's a vertical shift up, what? 49 over 8. Is that true? Just based on what we have here? Now, before I go further and close this down, because your quiz is going to be much like this one. Plus a little bit more, I'll tell you. Anyone tell me, if you're smart, you are, how might you as a clever student say, Professor, all this work going on here, all this business of completion of the square, I know I'm going to get nervous and I'm going to make a mistake and I'm going to put the wrong number here and it's going to throw everything off. How did you sort of slow yourself down after you get maybe to this point here, or back up here? How could you just sort of slow yourself down and go over to the side? What could you do for a little quick check? To see if you are correct at that time, so you will not turn in a paper that has a vertex wrong. Yeah. You could, something else. What? Yeah.
Use the vertex formula.
You can use vertex formula. We came up with a formula last week. Now make the complete formula look like this. To find the vertex right quickly, I think it's negative b over 2a. If I'm not mistaken, a little strange, I think I had that. The truth? This is the part, most important part, the negative b over 2. I'd slow down tomorrow. I said, wait now, Professor, after I get all this done, and I think the vertex is, for the x, 5/4, I'd quickly say, I'm going to check it right now and see if it is, by using the formula. That comes up to be 5/4, I'm feeling good. Okay, let's try this. So I got negative b back in my function, b was 5. And says twice a, and a back in my original function was a -2, looks like. Is that going to give me a positive 5/4 altogether? Does that agree with this? At least the 5/4. And that's where you start feeling a little bit better, and then go ahead and finish it up, get your 10 out of 10. If you are have the time, you can say, Professor, can I use this crazy thing? Plug in numbers and hope that it comes out to be that. You could. You use that 4ac minus b squared all over 4a business. Or, what else could you do to find or check the 49 over 8? Rather than using this is sometimes difficult to memorize. What else could you do? I can take what? F of?
5/4.
There you go. F of 5/4. So just take 5/4 back here, be patient, replace the x's by 5/4, crunch it out, and you should get that. There's some little checkpoints there. And then you graph it. Now I created this one real quickly. Now you know when you graph this, also I'm asked for the x-intercepts, y-intercept. What is this? We asked for, of course, vertex. It's going to open down. Beautiful. Domain, range. It's going to be a lengthy one problem there for that quiz tomorrow. Guys, before I leave this, I'm not going to graph this one completely for you, but you see what we did. We did the critical part here. Let me check and see if there are any x-intercepts. I'll create this one so quickly. Just find the x-intercept if we can. We set the y equal to 0. Let's go back to the original. Let's save here. And try to solve that quadratic. And like I said, I create this real quickly. What I like myself, this is up to you though. You could use quadratic formula. I'm going to rewrite this. I'm going to move everything over so it's better like that. I don't like those negative signs. It may factor. If it factors, then the quadratic formula would not have to be used. Guys,